sense now that we might have to do.
Okay, we're going to look at the definite integral from x squared minus, or of x squared minus 1 over the square root of 2x minus 1 dx. So use substitution. Why do I need it? Because when I try this problem right away, I see that I can't divide these. It's a quotient. We don't have the integral of a quotient. There's no quotient rule for integrals. I can't rewrite it in any way. I can't simplify this, so I'm going to go ahead and try use substitution. And I'm going to let u be the inside of the most complicated part here. And usually when you have a fraction, the most complicated part is always in the denominator most of the time. So I'm going to let u be the inside of the square root of 2x minus 1, which will be 2x minus 1. So when I go and start my u substitution, I can go ahead and get rid of this part by rewriting it as u to the 1/2. But now I have this much to get rid of, the x squared minus 1 dx. Well, let's go through. If I've got u equals 2x minus 1, then my du is going to equal to 2 dx, because I found the derivative and I separated the variables. So then I get 1/2 du is equal to dx. So I throw the 1/2 out front, put the du behind it. But now the problem is I've gotten rid of the dx, but I haven't gotten rid of the x squared minus 1. This is where you have to use your u substitution and do a change of variable. You're going to take this right here, and I've got to have everything in terms of u, so I'm going to take the x out. So I'm going to take this right here, this u equal 2x minus 1, and I'm going to change it and solve for x. And when I do that, I'm going to get x is equal to u plus 1 divided by 2. And that'll be my change of variable. So I can change that x over into an expression in terms of u. So I'm going to replace x with this expression. So I'm going to have u plus 1 divided by 2 quantity squared minus 1. Now I've done my u substitution. Everything is converted over from x to in terms of u. So I'm going to have my 1/2 out front. Start simplifying because there's always that rewrite step. This will be u squared plus 2u plus 1 divided by 4 minus 1 all over u to the 1/2. Now, I can't have this 4 in the denominator here, so I'm going to multiply the entire fraction, which by the way there's a du behind here. I'm going to multiply the top and bottom by 4 to go ahead and clear the fraction. And by the way, this is the second time I've done this problem. So 1/2 times the definite integral, distribute the 4, u squared plus 2u plus 1, because those 4's cancel, then minus 4. And the part I didn't do before is I forgot to distribute the 4 here. So it's 4u to the 1/2. Don't forget your du behind it. This integral will now simplify to 1/2 times the definite integral, or indefinite integral, of u squared plus 2u minus 3 over 4u to the 1/2 du. Now again, we don't have a quotient rule, so what I have to do is I have to take this quotient, and now I've got it into something I can simplify. I can separate the fraction. I can take each part divided by 4u to the 1/2, so I'm going to divide each one of these. So I'm going to have, this is going to end up being 1/4 u to the 3/2 plus 1/2 u to the 1/2 minus 3/4 u to the negative 1/2 du after I separate. Now I can integrate because we've done the rewrite step, so now I can find the integral of this using simple power rule. So we're going to have 1/2 times, add 1 back to the exponent, be u to the 5/2, and then divide by 5/2, which is the same thing as multiplying by the reciprocal. So if I multiply 1/4 by 2/5, the 2 is going to cancel the 4, you're going to end up with 1/10. Plus, this would be u to the 3/2. Multiply 1/2 by the reciprocal, which is 2/3. The 2's cancel, you end up with 1/3. Then I'm going to have u to the 1/2. Add 1 back to the exponent. Divide by that exponent, which is multiplied by 2. The 2 is going to cancel the 4, so you get minus 3/2. And then you're going to have your plus c. Distribute the 2 to all of this, and then go back and plug in your u. So you're going to get 1/20 u to the 5/2 plus 1/6 u to the 3/2 minus 3/4 u to the 1/2, and technically this c also gets multiplied by 1/2, but since it's a constant, we don't know what it is, we're just going to call it big C anyways. And then I believe if you go back to the top of the problem, we let u in the beginning equal 2x minus 1 right here. So now I can go back and replace, since this is an indefinite integral, we want to put it back in terms of x. So I'll take the u equal 2x minus 1 and substitute back in. So 1/20th u 2x minus 1 to the 5/2 plus 1/6 times 2x minus 1 to the 3/2 minus 3/4 times 2x minus 1 to the 1/2, and then my plus c, which is my constant of integration, and there you have it.